Have you ever wondered what gives titanium its amazing properties? How do they turn this ordinary rock into such a valuable metal? This is the incredible story of titanium. Hey everyone, have you ever marveled at the strength and elegance of titanium? This remarkable element, number 22 on the periodic table, has captured human imagination for centuries. It's strong, lightweight, resistant to corrosion, and found everywhere in the Earth's crust. But what exactly is titanium? And how do we turn it from raw rock into a metal used in rockets, airplanes, and even inside the human body? Let's dive in. Titanium was first discovered in 1791 in England by William Gregor, who identified it in mineral sand. A year later, the German chemist Martin Klaproth named it titanium, after the powerful titans of Greek mythology. Although it's the 9th most abundant element on Earth, titanium rarely appears in pure form. It's usually locked inside chemical compounds, mainly in minerals like rutile and ilmenite. That's why it took humanity so long to figure out how to actually use it. To get the metal, we need to extract it from these compounds, a complicated process that I'll simplify as much as possible. Don't worry, you don't have to remember any of this for the test. Just kidding. There will be a pop quiz later. Anyways, titanium has a strong bond with oxygen, making separation difficult. The most common way to achieve this is the Kroll process, developed in the 1940s. First, the ore is treated with chlorine gas and carbon at high heat, creating titanium tetrachloride, a reactive liquid. Then, it's reduced using magnesium in a vacuum at around 825 degrees Celsius. This reaction leaves behind metallic titanium in a porous form known as titanium sponge. From there, the sponge is melted and purified in massive furnaces, often with alloying elements like aluminum or vanadium. The molten metal is cast into ingots, which are later rolled, forged, or extruded into sheets, rods, or tubes. So why go through all this trouble? Because titanium has a combination of properties unmatched by most metals. It's 40% lighter than steel, but much stronger. It resists rust and corrosion, even in salt water. It can withstand extreme heat without losing strength. It's non-magnetic, which makes it useful in sensitive labs and equipment. And most importantly, it's biocompatible, meaning the human body accepts it without rejection. Because of these unique properties, titanium is used in many industries. In aerospace, it's essential for jet engines, rockets, and spacecraft like the James Webb Telescope. The fastest plane ever built, the SR-71 Blackbird, relied heavily on titanium. In medicine, it's used for hip replacements, screws, rods, and even dental implants. In sports and luxury goods, you'll find titanium in tennis rackets, bicycles, watches, and high-end cars like Bugatti and Pagani. And let's not forget, titanium dioxide, its oxide form, is the key ingredient in white paint around the world. Despite being abundant, titanium is expensive to produce. 1 kilogram of pure titanium costs over $100, compared to steel at just 50 cents. That makes it more than 200 times more expensive than steel. That's why titanium is usually reserved for industries where performance matters more than cost. Producing titanium is energy-intensive and creates waste, but the metal's long lifespan and recyclability help balance its environmental impact. New methods like the FFC Cambridge process using electrolysis promise to make titanium production cleaner and more efficient in the future. So, from aerospace to medicine, from art to technology, titanium continues to play an essential role in shaping our world. Its story is a testament to human curiosity and our relentless pursuit of innovation. Thanks for watching, and if you enjoyed this video, please stay tuned for more updates. Until next time.